address screen, there's abandonment on the payment screen, there's abandonment on the shipping screen, and then there's abandonment on the confirmation screen. So we're saying each of those 5 things is a little different. Now, reading between the lines, as the saying goes, what this is telling us is the judgment of the tester who designed this test that abandonment is a significant risk. The proper handling of abandonment is something that is at risk, and that's a reasonable thing to think. You know, that for one thing, when abandonment isn't handled properly and resources are not freed up after those resources are no longer needed, of course, then you have a resource leak. Anytime you have a resource leak, at some point or another, that's going to begin to create problems for you in terms of performance and in terms of reliability. So, you know, we don't want to have that situation. And also, you know, we're dealing with finances here, and abandonment means, you know, that something should not be charged, and we might, if at any point after we've gotten to the payment screen, after we've completed the payment screen, we of course have somebody's credit card information or PayPal information, however they're paying for it. We have that information, so it's possible that if there is a bug in the way that abandonment is handled, it could result in a inappropriate charge, which then is likely to be, you know, reversed, or if it happened too often, it could result in some sort of sanction. So it's a significant risk. But the key thing to keep in mind is, you know, as you're designing these tests, you know, well, do I need one test for an exception, or do I need, you know, what's effectively five tests here for an exception? Well, again, depends on the level of risk. If you think something's high risk, then, you know, you're going to use equivalence partitioning and boundary value analysis to identify multiple ways to test it, and you're going to do that as you see that we have done here. Okay, now this brings us to another point which is germane to testing in general, but is certainly brought up, I think, by the use case technique because of the way that the use case-based tests tend to look. This is this issue of logical versus concrete test cases. So what you saw just now on the previous 2 slides are what could be called logical or high-level test cases. They give test conditions and they give expected results at a very high level. The tester is expected to understand how to carry out a sequence of steps and generate spontaneously, in a sense, the data required at each of those steps, and is also expected to be able to determine what correct looks like with only minimal guidance from the written test case itself. And this is, to be honest, I mean, when I manage test projects, most of the time I'm working with testers who are reasonably senior people. And, you know, so this is the kind of thing that they can handle. You give them a test like that, and they're like, yeah, I can figure out how to do that. And in some cases, you know, maybe even less detailed than what was shown. Now, the logical test case is in contrast to what's sometimes called the concrete or low-level test case. So in the concrete or the low-level test case, you know, you have the actual input data itself. So instead of just saying test with American Express, as we did in the previous slide, you'd actually give an American Express card number and an expiration date and card verification code and all of that kind of stuff. I mean, everything would be specified. And rather than telling someone to verify a screen, you might actually show a mock-up of what the screen should look like, or maybe a previously captured and validated screenshot. So there might be a lot more detail well, there would be a lot more detail, excuse me, in a concrete or low-level test case. How much more? Well, quite a bit. I mean, it's, you know, I think you can, there can easily be a couple orders of magnitude difference between a logical test case and a concrete test case in terms of the amount of verbiage. Well, what I mean by that, a couple orders of magnitude, is that if you look back on the previous slides here, we back here, this is pretty sparse stuff, right? I mean, it's just not, there's not a whole lot of verbiage in here, so maybe what, 40 words, something like that. Now, imagine if we had to show, well, no, not okay to be imprecise like this. I want to see what the screen looks like when the cart is empty. I want a screenshot. I want to see what the error message looks like. So I want to see each one of these error messages, and I also want to see that the next button is grayed out. So I'm going to show that that's supposed to happen. And this shown as entered, well, no, what exactly is to be shown when we verify the order, right? So not just an item, which item, right? What does the checkout button look like or screen? What invalid address and then subsequent valid address? What invalid payment? Subsequent valid shipping. So you can easily go from 40 to 50 words to 400 or 4,000 words potentially in something like this. Now, do we need to do that? Well, that there are cases where you do need to provide that level of detail, but fortunately they're limited to certain circumstances, right? I mean, regulated medical devices, for example, in the United States and Canada, Food and Drug Administration is going to require that you have that kind of auditability of your tests. So, if you're in that line of work, then you're going to have to go to the next step with these things, translate logical test cases into concrete test cases and have that level of documentation available. If you're not, then you need to ask yourself, well, what is the appropriate level of detail for auditability and repeatability, et cetera, on our environment, and come up with the right answer. It might be as high level as what I showed you, or even more abstract than what I just showed you, or it could be more concrete, but not necessarily down to the specific values and steps, et cetera. So now bringing us back to use cases, if you're creating tests based on use cases, you can see the translation of a use case into a logical test case is very easy. A lot of the verbiage that was in the use case is straight replication into the test case, right? So a very, very straightforward kind of process. Now, given a logical test case such as the one shown, if you do need a concrete test case, then it will be a matter of just going through and refining and adding more detail to it. But consider this carefully. This is probably a topic for a subsequent webinar, I would guess, about appropriate level of detail in test cases and so forth, because this is something that people find very difficult to get their head around, of how much do I need to document. And the right answer is obviously exactly as much as you need to document and no more, but that doesn't really answer that question. It kind of throws you back into it. So subsequent webinar, if there's interest, if some of you think that this is a topic that deserves a full 45 minutes of discussion, send me an email and we'll do one. Okay, now what I showed you before was an informal use case. Let's move on and look at a more formal use case, which you might be lucky enough to receive. So in the case of a formal use case, you've got additional things like an identifier. You've got usually a short name of the use case. People remember it. The actor will